last time we made our polygon move across the screen by writing a translate function for it. And as you know, our polygon is an array 1 to 6 of real values. But what we're going to do now is make it rotate. And we need to change a little bit of the programming just to make it easier for us later on. It's not hard at all. We're just going to create a new type called a vertex. A vertex is an array 1 to 2 of real. Basically, it's just a small array that holds an x and y value. So 1 would be x and 2 would be y. That means you have to change a polygon from an array of real to an array of a vertex. And it'll obviously only go 1, 2, 3 because there's only 3 vertices that make up a polygon. When you reference a vertex as x, so say we want the first vertex as x, you're just going to go whatever the polygon's name is, first vertex, first value, and that's the x. If you want the y of that vertex, you go 2, and that'll give you the y of that vertex. Easy as that. That means we're going to have to change something else quickly, which is first the draw line procedure over here is not going to take in 4 values anymore. It's going to take in v1 and v2, which are a vertex. So we'll quickly go to its declaration and change that as well. Draw polygon takes in a polygon, that's fine. Function translate polygon takes in a polygon, that's fine. We don't need to change that. So our draw line now has to take in v1 and v2, which is a vertex. Then quickly add xa, xb, ya, yb as real values into the variable section, just so we don't have to change all of the code over here, so it'll still work with that. And then just below the begin over here, just add xa is v1 x value, xb is v2 x value, xa is a vertex 1's x value, xb is vertex 2's x value, ya is vertex 1's y value, yb is vertex 2's y value, and the rest of the draw line function will work just as it should. Then draw polygon takes in a polygon, which is fine, and then you have to change the draw line from taking in 4 values to just taking in 2, which is polyin's first vertex to polyin's second vertex, then polyin's second vertex to polyin's third vertex, then first to third again, and that draws your triangle just like we said. So from first vertex to second vertex and so on. Then on form create, where we created our test polygon, you know, our temporary polygon that we draw on the screen, instead of entering every x and y value, you're going to enter the vertices x and y value. Test polygon 1, which is now not the x values anymore, these are the vertices. And we have 3 vertices, so let's quickly copy these values. So our first vertex is x value, which is the first value in that array, is this. Second vertex is x value, is this. Third one is this. Again, we will start with the first vertex, then the second vertex, then the third vertex. And this is going to be all the y values, so just add a 2 behind that, because you're referencing vertex number 1's y value, or vertex number 3's y value. Translate polygon takes in that, that's fine. Then we have to change how translate polygon works quickly. The first vertex is, now the first vertex's x value, or well, the vertex i's x value is equal to vertex i's x value plus x, vertex i's y value plus y. Okay, translate polygon, timer, that's fine. Draw polygon, test polygon, so everything should work fine. Now let's run it, and you can see that it works as it did before. We've just added vertices instead of using raw numbers. Now, to start with the rotations. What we want to do is we want to be able to first rotate a vertex around a point. So we're going to create a function called rotate vertex. And it's going to take in, let's just call it vertex in, which is a vertex. Then we're going to give it the x and the y of the point we want to rotate it about. X and y, real values, and then we also have to add a value called theta, which is our degrees we're going to rotate it about, and that's going to output a vertex. So let's quickly drop that down with Ctrl+Shift+C. So rotate vertex. Many of you may have done this in math to rotate something about the origin, and you know that this is the formula for the new x and the new y after the rotation. So x is equal to x times cos of the angle minus y times sine of the angle, and the new y is y times cos of the angle plus x times sine of the angle. So let's quickly create a variable here called temp vertex, which is a temporary vertex, which is still a vertex, then temp vertex's x value, which is a new x, is equal to vertex in's x value times cos of theta minus vertex in's y value times sine of theta. So let's quickly copy this just for speed. Then the y value of temporary vertex is going to be y value cos plus x value times sine plus x value times sine, and result is temp vertex. So let's quickly test that out. Let's go to our timer function. We'll make it rotate on each timer call, and remember this works in radians, not degrees. We're going to say test poly, the first vertex, is equal to rotate vertex of test poly. I'm just going to add the x and y values of our point in for now, even though it doesn't do anything yet. I want to show you what it does if you don't have an axis to rotate about. And then we're going to enter how many degrees it has to rotate by, so 0.01 radians. And you can see that the point is rotating, but it's rotating about the origin. And so what we're going to have to do now is the following. We want it to rotate about a certain axis. So as you've noticed, it rotates about the origin. So if you have a point over here, it rotates around there. Say our vertex lies over there, and we want it to rotate about this point over here. What we're going to have to do is move the entire system so that this point lies on the origin, like that. And what will happen then is we rotate it. So in other words, this will rotate around wherever we want it. After we've done the rotation, we take the entire system and we move it back to where it was, and that'll give you a rotation around that point. So let's quickly go back to Delphi over here. So we're going to translate our system so that these coordinates are at the origin, and then rotate it and then translate it back so that these coordinates are where they used to be. Then we're going to return the result, and it'll give us our vertex rotated around that point. So we're going to take temp vertex is equal to vertex in minus x. The y value of temp vertex is going to equal to vertex in y value minus y. Then temp vertex x is going to be equal to temporary vertex x now, because we want to use the new values we gave it. So change all of these into temporary vertex, which now has the translated values of that. It rotates it, then temp vertex is equal to what it was, plus x and plus y, which will turn it back to its normal value. Let's run this and see what happens. And you can see that this vertex is now rotating around this point over here, which is 100, 100. Now that we have rotate vertex, let's make a rotate polygon, which will be very easy. Just like we draw the lines, we just rotate all the vertices of the polygon to rotate the entire polygon. So function rotate polygon. So poly in is a polygon, and we're going to rotate it about the x and the y of what we give it, and theta, which are real values, is going to output a polygon. Drop that down, and then so let's create a variable here called temp poly, which is a polygon. Then temp poly's first vertex is going to equal to poly in's first vertex rotated. So let's call our rotate vertex function rotate vertex, and we give it poly in's first vertex, and we want to rotate it about the x and the y that we give the rotate polygon. So x, y, and it wants theta, which is just going to be theta that we sent the top function. So copy this 3 times. You can run a loop through it, but I mean, this is so small I wouldn't bother with it. 1, 2, 3, 1, 2, 3. So all the vertices are now rotated around those points. So result is temp poly. Let's quickly go to our timer where we rotated the first vertex. Now we're going to rotate the entire polygon. So we're going to say test poly is equal to rotate polygon, and we're going to give it test polygon, and we want to rotate it about the point 100, 100 again, and we want to rotate it by 0.01 radians each time. Let's run this and see what happens. And you can see that our entire polygon, it's off the screen now, we'll come back now, is being rotated around the point 100, 100. Now obviously it starts the rotation from where the polygon originally was to where you wanted to be rotated around. So if we were to make this value very close to the triangle, let's guess it's at 200 and 200, it'll obviously rotate it around that point now. So if you want to rotate the actual triangle in the position that it is, all you have to give this function is the triangle's current position. Now that position could change depending on the center of gravity of the triangle, or depending on the shape of the polygon or something like that. But we're going to quickly write a function called find centroid. And the centroid of a triangle is simply if you take the middle there, and you draw a line from each tip to the center of each side, then this intersection over here is called the centroid. If you have a flat sheet of paper or something, that'll be the center of gravity of the triangle. So it's a very good base to start with. Let's quickly write that function. It's actually very easy, because all you do is you average all the x's and you average all the y's. So function find centroid takes in poly_in, which is a polygon, and it's going to output a vertex. We can't output two values because it's a function, and functions only output one value, and so it helps that we created the new type called a vertex, because now we can just output a vertex and it'll give us the x and the y in the form of one variable, a vertex. So drop that down, then we're going to create a new temporary variable here, so variable temp vert, which is a vertex. Begin with temp vertex's x value is equal to poly_in's first vertex's x value plus poly_in's second vertex's x value plus poly_in's third vertex's x value. And so we add all these up together, and then we divide it by 3 because there's 3 of them, and that'll find you the x value of the centroid of that triangle. Now for the y, we just copy this again, bam, 2, and obviously this will be vertex. All these values will be changed to 2 for the y, and the result is equal to temp vert. So now we have a function that finds the centroid of a triangle. So let's go to our timer over here where we keep on rotating the triangle, and instead of giving it random values, we're going to give it the values that we worked out to be its centroid. We're quickly going to have to create a variable here, which is going to be a vertex. So center vert, I'm going to call it, is a vertex, and center vertex is going to be find centroid of test poly. So instead of the 200 values, we're going to now give it center vert's x value and center vert's y value. And you can see that the triangle is now being rotated around its centroid, or the center of the triangle. And you can see, because we are working from the centroid of the triangle, even if we move the triangle, it'll still rotate around the center of the triangle, because it's calculating the centroid each time. Now, even though it's being rotated around its center, the problem is that computers have floating point error, because computers don't have an infinite amount of accuracy. The accuracy of the vertices are going to be lost as it's being rotated the whole time. And you'll see that if I increase the speed of the rotations over here, the triangle is actually going to be deformed very quickly. And I will discuss how to get around that later. It's actually not that hard. It's just to understand the concept. And as you can see, the triangle is getting smaller and smaller as the floating point error increases. But we don't have to worry about this floating point error, because the way we're going to use the engine, we're going to avoid it completely. We're going to get into detail with it later, but just to satisfy some curiosity. When we create a object class in whatever program you want to use this in, such as say it's a box, and a box is represented by 2 polygons, which is 2 triangles. It has additional properties such as mass, velocity, and rotation. So your rotation is going to be stored by a single variable, and you'll have position, and as the game or application progresses, all you're going to change are these values, either the rotation or the position. Either the rotation, you're going to add rotation to it if it has angular velocity, but the actual model, the vertices, will never change. Then when we call our draw function, you're going to take these values over here and you're going to apply it to the model, and you take whatever other properties you have and you apply it, and then you draw that. But the actual vertices, you draw a temporary polygon. The actual polygon is still in its original place of original rotation, so it never gains any floating point error because you keep on referencing from it.